Yo everyone, welcome to this video. I'm Pranav C and today I'm going to walk you through the fascinating world of embedded systems, how they're designed, the unique challenges they bring, and why they're quietly revolutionizing everything from your kitchen to the sky. Let's dive right in. To understand why they matter so much, we need to start with the basics. What exactly is an embedded system? An embedded system is a mini computer designed to do one very specific job, and it's usually built right into another device. Unlike your laptop, which can open 10 tabs, run Spotify, and crash at the worst moment, an embedded system stays focused. It might be reading a sensor, adjusting temperature, or controlling a motor, and it does that one job really well 24 bar 7. It has to respond in real time, like an airbag system that deploys in milliseconds, and it must be super power efficient, especially in wearables or IoT devices that run for months on a single coin cell. And guess what? They're all around you. Your smartwatch, embedded system, your microwave, embedded, the washing machine in your home, yep, that is also an embedded system. Honestly, the device you're watching this video on has multiple embedded systems working behind the scenes. Now that we know what it is, let's peek inside and see how one of these little powerhouses is built. Under the hood, every embedded system is made up of four key ingredients: a processor, that is usually a microcontroller or a microprocessor, like the brain of the operation; memory, both RAM for temporary storage and flash or EEPROM to hold software permanently; peripherals, these parts are the hands and ears; timers, ADCs, GPIOs, and communication ports like SPI, UART, and USB-C; and of course, software, typically called firmware, that tells a system what to do and when to do it. Everything is tightly integrated. That's what allows embedded systems to be compact, low power, and lightning fast. Now let's take a closer look at the tools, both hardware and software, that make all this magic happen. On the hardware front, one name dominates: the ARM Cortex-M family. These microcontrollers are in everything from smart bulbs to fitness trackers. For more demanding applications, however, engineers resort to FPGAs or ASICs. Add to that sensors like temperature or accelerometers and actuators like motors or LEDs, and we have a full control loop. Now, for software, the real brains, which is typically called firmware here, is usually written in C, C++, or even Rust for low-level control. If timing is critical, you will often see a real-time operating system like FreeRTOS or Zephyr managing tasks precisely. So it's not just about tiny chips, it's a full stack engineering effort. With so many moving parts, embedded system design follows some golden rules. Let's talk about those. Designing an embedded system is like walking a tightrope. Here are the four principles you can never ignore. Optimization. Everything must be efficient. Power, memory, cost, and even lines of code. Reliability. The system must never fail. Think of pacemakers or aerospace systems. These can absolutely cannot fail. Real-time processing. Some systems can't afford to be late. Airbags must respond in under 1 millisecond. Security. With smart devices everywhere, securing data and blocking unauthorized access is absolutely essential. Every engineer working on embedded systems has to keep these four in check all the time. Sounds intense, right? Well, it is. Let's talk about some of the biggest design challenges next. Designing embedded systems can be a real test of engineering creativity and endurance. Here's why. Resource constraints. These systems often have a teeny tiny processor, a few kilobytes of RAM, and no hardware, so every byte counts. Power management. If your device is running on battery like a fitness band, it needs to last weeks or months. That means ultra low power components, sleep modes, and careful code optimization. Security vulnerabilities. Because many embedded devices connect to the internet, they can be targeted by malware. The infamous Mirai botnet took over thousands of unsecured IoT devices to launch attacks. Time to market pressure. Companies want devices faster, cheaper, and better all at once. This puts pressure on teams to deliver robust systems without cutting corners. It's like building a spaceship with Lego bricks and the timer ticking down. Despite the challenges, embedded systems are absolutely everywhere. Let's look at some exciting use cases, starting with the ones closest to us: consumer devices and IoT. In our daily lives, embedded systems are everywhere. Smart homes use devices like Philips Hue and Google Nest to manage lighting and climate, all controlled by embedded controllers. Wearables like smartwatches track your steps, heartbeat, and even your sleep. Medical devices like pacemakers and glucose monitors rely on real time embedded systems for life saving precision. Consumer electronics, from TVs to drones to robot vacuums, wouldn't function without them. And get this, the global IoT market is projected to hit $1.3 trillion by 2026. That's a massive field powered by some of the tiniest computers ever made. Let's shift gears from the living room to the car and even to the skies. Embedded systems are also transforming transportation and industry. Let's start with cars. Modern vehicles contain over 100 embedded computers called ECUs. They manage engine performance, infotainment, safety features, and even autonomous driving. Then we have aerospace. A plane like the Boeing 787 uses over 100 embedded systems from navigation to flight control to in flight entertainment. In factories, embedded systems power PLCs and robotics, enabling precise automation that's changing how products are made. So, whether you're on the road, in the air, or on the assembly line, embedded systems are at the core of it all. But it just doesn't stop there. The future of embedded systems is even more exciting. Let's peek into the future, and it looks brilliant. Edge AI is bringing artificial intelligence directly into devices, like smart cameras that detect objects in real time without cloud access. Enhanced security is happening at the hardware level. Secure boot against root of trust help devices verify their identity and protect against tampering. Low power wide area networks like LoRaWANs and NB-IoT are connecting sensors across cities with ultra low energy, and RISC-V, an open source chip architecture, is opening the floodgates for innovation and custom hardware. These trends are pushing embedded systems to be not just smart but intelligent, secure, and adaptable. Alright, let's wrap it all up and zoom out one last time. So here's the bottom line. Embedded systems are the invisible intelligence behind almost every device we use. They demand interdisciplinary skills from hardware design to software engineering. They're foundational in sectors like IoT, automotive, medical, aerospace, and beyond. And they're evolving into smarter, more secure, and more connected systems with each passing year. Whether it's a smart fridge, a drone, or a heart monitor, there's an embedded system quietly doing its job, never asking for attention. Thank you so much for watching. I hope you have enjoyed this journey into the tiny giants of technology. Until next time, signing out.